In this exercise, you need to understand everything about the properties of the straight lines and also the properties of the shapes, talking of the parallelogram, any shape that you might be having in your syllabus. So we shall quickly rush through the questions that we are given. The first question that we are having in this exercise is that ABCD is a parallelogram. So there we have to consider the properties of a parallelogram, since we have a parallelogram in order for us to answer the questions that follows. All right, then from there we are also given that with AE perpendicular to BC. So this is for perpendicular to. Remember, if it is like this, it means parallel to. If it is like this, it means parallel to, like AD is parallel to BC. We can say AD is parallel to BC, but this one is perpendicular to, meaning to say they meet at 90 degrees. From point A to E, it is at 90 degrees to the line BC. They meet at 90 degrees. That's the indication of a right angle that we are seeing there. So that's it, guys. We've got a right angle at 90 degrees. That means also here there is a 90 degrees. Remember, angles on a straight line. All right, so that is what we're given. And with this, we're asked to calculate with reasons the values of these A, B, C, D. All right, remember the properties of a parallelogram. Opposite sides, they are parallel and also equal. But in this case, we want to consider the issue of the parallel lines. So these opposite sides, which is AB and BC, they are also parallel and equal. And we must also consider that in a parallelogram, also opposite angles. I said in any parallelogram, you must understand this. In any parallelogram, we are going to see that opposite angles are equal. Opposite angles are equal. In any parallelogram, opposite angles are equal. So there is a lot that we can consider there to find all these angles. All right, so let's see, guys, what we have. Let's start with A. We're going to start with A in this case. All right, so A, this is it. There we have got parallel lines. We are forming a C like this. All right, we are forming a C. Remember, when you form a C, these are co-interior angles. So meaning to say we can calculate A. A is simply going to be 180 degrees minus 75 degrees. Co-interior angles, they are supplemented. They add up to 180 degrees. If you're just considering two angles like that, they add up to 180 degrees, means say they are supplementary. Whether they are 3, they are 4, they are 5, those angles will add up to 180 degrees. But if they are 2, it's a special name, supplementary. Okay, just like that. So that's our point. That's our angle A in this case. So this we considered where we form a C. These are co-interior angles. So there we talk of the co-interior angles. Co-interior angles. Since these two lines are parallel, AD is parallel to BC. Since AD is parallel to BC. Okay, so that's it. We've got our A there, which is 105 degrees. So let's say this is our A, 105 degrees. Let's move on to another angle. All right, B. What about B? B, we can state this. We remember these lines, they are parallel. AB is parallel to DC. So if you check here, we are forming a straight F. Let me just use this one. We are forming an F here, corresponding angles. Look, that's an F that we are forming there. An F, corresponding angles. These two angles are equal. So 75 is equal to B. Those are corresponding angles. So that was a straightforward solution for B. B is simply equal to 75 degrees. These are corresponding angles. So we are simply talking about the corresponding angles in that case. All right. So these are corresponding angles. All right. Since these two lines are parallel, DC is parallel to AB. From our parallelogram concept, DC is parallel to AB. These are the properties now that you have to consider of a parallelogram. So we've got angle B. Let's move on to another angle, which is C. Can we calculate the angle C at this point? Yes, we can. We can even state this. C is opposite to D. Remember, this angle C is opposite to D. Remember what I said, in any parallelogram, opposite angles are equal. So that means we can state the angle C. C is equal to 75 degrees. So thus we've got 75 degrees at C. From this concept, opposite angles are equal in a parallelogram. So you can simply state that opposite angles are equal. So I'm just going to write in short, opposite angles. All right, opposite angles are equal in a parallelogram. So I'm just going to write in short, in a parallelogram. All right, so that's the major concept that you have to consider about opposite angles. All right, so thus we've got C. What about D? This is where our D is. So to calculate D, there were actually so many ways that we can use. Since these two lines are parallel, we also have C there that we are forming. Look, we are forming a C here. We are forming a C. So meaning to say, we can consider co-interior angles to that 90 degrees. So meaning to say, our angle D was simply going to be 180 degrees minus 90 degrees. These ones, thus therefore, our angle D was simply going to be 90 degrees. That's co-interior angles. So there, we are talking of the co-interior angles. That's the reason that you're going to write there, a co-interior angle, since AD is parallel to BC. So that's it. We have got our angle D, which is 90 degrees. All right. Another way that we could have calculated angle D, there are so many ways that, guys, that we could have used. To calculate angle D, we can consider that this is a quadrilateral from A to E to C to D like this. This is a quadrilateral. And we do know that angles inside these interior angles in a quadrilateral, they add up to 360 degrees. Is it a kite? Is it a rhombus? Is it a square? Is it a triangle? Is it a rectangle? As long as it's a quadrilateral, they add up to 360. So we can calculate D by subtracting these angles from 360. So that's 360 degrees. We subtract the 75 degrees. We subtract the 105 degrees. We also subtract the 90 degrees. If we subtract these three angles, we are going to remain with angle D, which is the one that we need in that case. So that is how you could have calculated this. You are going to simply obtain the same answer of 90 degrees. As long you do understand the reasons that you're going to use, as long as it's a geometrical reason. All right. There are so many ways that we could have used. We could have calculated this angle at A, which is BAE. Then you use angles on a straight line. Guys, there are so many ways that you could have used. So in that case, we could have used the concept of opposite angles. All right, it's going to limit us because we do not have this one, but you have to calculate this first. That is angles inside of a triangle, adding up to 180, then you calculate your angle D. So many ways that you could have used. As long there is a geometrical reason, you are supposed to apply that. All right, let's check another question. There is another question here that we need to consider. There we are given, that is item 1. A, B, C, D is a parallelogram. So there we are given A to B to C to D. All right, this one, I'm just going to try indicate it so that, all right, let's try from A to B. Okay, why is it so like this? Okay, let me just try this one, guys, so that we properly see. From A to B, like this, going to C. All right, going to D, like this is a parallelogram, this one. So they are saying this here is a parallelogram. So thus by being told that this is a parallelogram. We can also consider the concept of a parallelogram. Remember, opposite sides are parallel. So it means AB is parallel to DC. From this concept, AB is parallel to DC or CD. Also, AD, this AD is parallel to BC. So A to D is going to be parallel from B to C. These are the properties that you just know of a parallelogram. By just being told that it is a parallelogram, you must know this. Then we are given the angle B1, 90 degrees. That is what we can see here. There's a 90 degrees there. A, 70 degrees. So the first question was, number one, calculate with reasons the size of these angles. All right, so let's see. D1, D2, and so on. So let's start with angle D1. Okay, this is angle D, and there we've got D1. All right, D1, we can simply use angles in a triangle. Since there's a 90 and 70 there, we can simply use angles in a triangle. So you see now the properties of a triangle, they do work at the same time. So it means our angle D1, we're simply going to subtract. Remember, angles inside a triangle, they add up to 180 degrees. So that's 180 minus these two angles that we are given, the 70 degrees and the 90 degrees. We subtract these two from 180 degrees. Since angles inside of a triangle, they add up to 180, you're going to obtain 90 degrees. So the reason there, we're going to consider angles in a triangle. In a triangle. So I'm just going to write in short like that. Angles in a triangle. Thus, they add up to 180 degrees. So you subtract the other angles from 180 degrees. So that's we've got this angle D1, okay? Let's move on to another part, D2. How can we obtain the angle D2 from what we have right now? Okay, if you are limited, like you have a question that you're answering and you're actually limited, you can leave that, but yet you can answer this one. They are hiding something here. I want you to see it. Let me choose something that can be clear here. If you check from A to B like this, going here to D2 like this, what are you forming there? That's the same concept of a Z or an N. Alternate angles. We are forming a Z there. So this is 90. This D2 is going to be 90 degrees. Those are alternate angles. So D2 is equal to B1. Sorry, this is here, B1. It is equal to angle B1, which is equal to 90 degrees. These are alternate angles. We are forming an N, like that Z concept, the any concept there. That is exactly what we need. This one and this one must be equal, alternate angles. So these are alternate angles. I'm just going to write in short, alternate angles. Okay, since DC is parallel to this BA or AB parallel to DC. All right, since AB is parallel to CD or DC, like that. These two, they are parallel. All right, let's move on to another angle. So we've got 90 degrees. Also, when answering, fill in your diagram. You're answering something, fill in your diagram so that it can help you to say this angle, it can help you to find another angle by filling in your diagram. Do not leave your diagram empty. Fill in. All right. Let's move on to another part that we can calculate. We can have B2. Actually, here we can see that this here from the concept of a B2 and this other side. Remember what I said about the parallelogram, about the opposite angles. Or you can consider, there are so many ways. Okay, let me start with the one that is clear about B2, then we move on to another one. Let me start with this one. Since these two lines are parallel, we can see that we are forming a Z here. Okay, that's it, a Z. So this angle D1 and B2, they are equal. We are forming a Z, the alternate angles. So D1 and B2, they are equal. So thus we can calculate angle B2. If these two are equal, angle B2, this one, okay, remember guys, your Z here. Alternate angles. So B2 is equal to angle D1. And we have calculated angle D1 before. You see what I was saying? That it is important that you do indicate it on your diagram. So that is 20 degrees. So there we have got 20 degrees, thus alternate angles. So there we're simply going to give same reason of alternate angles, but not from these two lines, but from line AD and BC. So that's the reason, alternate angles there. Alternate angles, since line AD is parallel to BC, all right? So from the lines that are parallel, AD is parallel to BC. Remember that. All right. So these two, they are equal, alternate angles. Let's move on to another part. We can also calculate B3. Where is our B3 from our diagram? That is B3 here. All right, but before that, remember I said you can also calculate the same B2 in another way. This is another way that we could have calculated angle B2. Remember what I said about a parallelogram, opposite angles are equal. In a parallelogram, opposite angles are equal in any parallelogram. So what does it mean? It means that angle D, the whole of angle D is equal to the whole of angle B combined. That is B1. This is what it means, guys. Angle B1 plus angle B2 combined. The whole of this angle combined, B1 and B2, must be equal to angle D1 and D2 combined. Must be equal to angle D1 plus angle D2 combined, like that. These are opposite angles in a parallelogram, just like even for C2. You can even use it for C2 here. This angle C2. C2 is opposite to A in this parallelogram. These two, they are opposite. A and this C2, they are opposite. So if this is 70 degrees, it means also C2 is 70 degrees, but we are not referring to that one for this moment. So I'm just saying you can use this one, then you can use angles in a triangle to calculate what? To calculate angle B2. So many ways. All right, let's use this one and see the one that I'm saying here. You're going to substitute. Remember, we have got all these. B1, we have it, which is 90 degrees. So 90 degrees plus angle B2 that we need to calculate. So this is another way, remember, that we could have used, is equal to D1. We have got D1, which is 20 degrees, plus D2, which is 90 degrees. We want to calculate or find B2, so you're going to take the 90 degrees to the other side, and it becomes a minus. So that's angle B2 was going to be 20 degrees plus 90 degrees. Taking this 90 this side, it was going to subtract. It was going to be a minus. So that's it. These two going to cancel. You remain with 20 degrees. So that's our angle B2, or you can just use your calculator to simplify everything. You obtain the same 20 degrees that we obtained previously. So as you can see, there are so many ways that you can use to calculate whatever that you're given. All right, let's move on to our B3. This is where B3 is. In this case, we can simply use the concept of angles on a straight line. B1 plus B2 plus B3 must be equal to 90 degrees, must be equal to 180 degrees, sorry, angles on a straight line. So angle B1 plus angle B2. Okay, let me just use as they are, guys. We know this angle B1 is 90 degrees plus angle B2, which is 20 degrees. We calculated this, plus angle B3 must be equal to 180 degrees. This we are referring to the angles which are on a straight line. So these are angles on a straight line. So there, you're going to talk of angles on a straight line. On a straight line in that case. All right. So thus we have formed an equation which we can use to calculate our B3. So we can solve for B3. that is simply subtract these angles that we are given. 90 this side minus 20 that side is going to be a minus. So we are going to subtract 90 degrees, 20 degrees at the same time, thus obtaining angle B3. That was going to give us 70 degrees in that case, all right? So that's our angle B3, which is this one at point B3. This angle was going to be 70 degrees. Okay, so we have calculated all these angles. Our everything actually is complete on question number 1. Let's move on to question number 2. So that is how questions might be given. You just need geometry. You need to work as much questions as you can. That is the part of geometry. For you to understand it, do as much revisions, as much questions as you can. You actually see that it will be a repetition throughout. Number 2, prove that BECD is a parallelogram from B. All right, let's see what are they trying to ask here. All right, let's see. From point B to E to C to D. This one is a parallelogram. All right. Remember the concept of a parallelogram, guys, that we can consider the issue of the parallel lines. We can consider if opposite sides are parallel. We can consider the issue of the opposite angles, any reason that you can use for the parallel lines. All right, that's for us to prove that it's a parallelogram. Okay, so in this case, D2 is 90 degrees. All right, so let's see what is happening here. Angle D2 is equal to 90 degrees. We are already given that, or we calculated this. Okay, and this is happening at angle C, which is DCE, the whole of angle DCE. This whole angle DCE is 90 degrees, 70 plus 20 degrees. Okay, we are going to obtain what? 90 degrees. Okay, what is the relationship that we do understand on lines? If two lines are given, then you obtain an angle of 90 here, you obtain an angle of 90. What is it about these two lines? There is no way that these two angles here inside will add up to 180 degrees and these two lines are not parallel. No, there is no way. The moment that these two angles add up to 180 degrees, it is a definite issue that we have to consider that these two lines are parallel. Why? Remember, co-interior angles where you form a C. Co-interior angles, they add up to 180 degrees. So by this, it simply tells us that these two lines are parallel. BD is simply parallel to EC. These two lines, they are parallel. So therefore, we can consider the shape that we are given, BECD, to be a parallelogram, all right? Is a parallelogram. Parallelogram. That's it. Why are we saying this? Remember the properties of a parallelogram. Opposite sides are parallel. Remember those properties. Opposite sides are parallel. Opposite sides are parallel. So that's it. Or we can consider the issue of opposite angles. Remember I said in any parallelogram, opposite angles, they are equal. This is 90, this is 90 opposite angles. That was going to happen at D2 and E2. That's another way that you could have used. Then now we need to prove that this same shape, BCED is a rectangle. This is the same shape, guys, from B to E. Now they are saying this way. Okay, this one. Look the way that they want to confuse you guys. They are calling it like this. B, C, E. Look, a shape is not supposed to be given like that. A shape is supposed to be given following B, D, CE like this, okay? Not to confuse like this way. It's supposed to be, okay, so guys, you see these textbooks also, the way that they want you guys to be confused. It's just the same B. You form a shape this way. If you are moving like, you must move like this, B, E, C, D, like that, okay? Or you can call it B, D, C, E. That's reasonable, okay? So this is B, E, C, D. Okay, that's the same shape that you had. E is a rectangle. How can you prove that this shape is a rectangle? Remember, a rectangle is a parallelogram with an interior angle of 90 degrees. So we are supposed also to work about these shapes separately, but I think I talked about this on a separate video about these shapes. So make sure that you do watch that part also. All right. So we can consider that it is a rectangle, this one. Okay. We are already proved that these two sides are parallel. All right. We already proved that BD is parallel to EC. It's already proven. We already proved this, or we have already given that. Angle D, these ones, they are equal. This part and this part, they are equal. And we have already proved that angle D2 is equal to angle D CE, which is actually angle C, which is 90 degrees. There is no way that these two will be parallel. And there we have got interior angle of 90 degrees. No, there is no way. That will be a rectangle. So therefore, therefore B, ECD is a rectangle. Is a rectangle. Remember, that's a parallelogram with an interior of 90 degrees. That's a parallelogram. That's a parallelogram with an interior angle of 90 degrees. With an interior angle of 90 degrees. So that's the properties that you need to know. Remember your properties. I want you to work from your properties. Do you understand your properties, the properties of the shapes? In order for you to prove that, you must know the properties of the shape. All right. On another question, we are given ABCD is a trapezium. Remember, a trapezium, it only has one pair of parallel sides. That's a trapezium. It only has one pair. And that is the one that we are given here with AD parallel to BC. AD and BC, they are parallel. It only has one pair of parallel sides. These ones, they are not parallel. These are the properties that you need to know of a trapezium. You need to know the properties of the shape that you are given. What is it about that shape that you are given there? What is it about the shape? All right. Then we are also given, this is after being told about being parallel. These ones are not the properties. This is about the question on its own. It has additional properties that you are given. Not to say whenever you are given a trapezium, this must occur. No, this is just about this question where they are saying AD is equal to BD. AD and BD, they are equal. That is the indication that we are seeing of these two that we are seeing here. This is to show us that they are equal. Remember what I said about these from a triangle. It means the angles opposite these sides must be equal. Remember the concept of your triangle. So meaning to say this angle and this angle must be equal. We know that. In the same sense, we are also given that BC is equal to CD. From B to C and from C to D. That's why we are given also the indication to show that these two, they are equal. So we do understand the angles opposite. You take this C, you take this to D. So it simply means C is equal to D. You must understand that C will be equal to D. All right, then we are given an angle A being 78 degrees, this one. From that, determine the unknown angles. That is our question. Determine the unknown angles. That is A, B, C, D, whatever that you're given the inside of this shape. All right. So already we calculated A. We stated this angle A. Remember, I said A is 78 degrees. Thus, angles opposite what? Equal sides from the triangle concept, or an isosceles triangle concept. All right. So these are angles opposite equal sides. Opposite equal sides. Definitely they will be equal. Then we can also calculate the angle B, since we do understand that angles inside of a triangle, they add up to 180 degrees. So the 78, the B, everything must add up to 180. So we are simply going to subtract these two angles from 180. We subtract the 78. We also subtract the other 78 from 180 degrees. That was going to give us angle B, since angles inside of a triangle add up to 180 degrees. So that was going to be 24 degrees. So the reason is angles in a triangle add up to 180 degrees. All right, so we've got angle B. Then what about angle C? Let's see the C here. These two sides are parallel. So we can use the concept there. We are forming a Z, alternate angles, where you form a Z. Remember your alternate angles. If these two lines are parallel, these two angles are equal, alternate angles. So from this case, angle B is equal to angle C. So C is equal to B, meaning to say it is equal to 24 degrees. These are alternate angles. So we are simply talking of what? Alternate angles, since we are given that AD is parallel to BC. That's the idea there. So we have got 24 degrees here. But remember what I said about C and D, that they are equal before, from this concept of the angles opposite equal sides. So by having C, we are also having angle D. Angle D is equal to 24 degrees. So the reason is going to be angles opposite what? Equal sides. So having angle D, it was going to help us to calculate angle E. Since ADC is a triangle, so you can consider angles inside of a triangle to add up to 180 degrees. Just like how we calculated angle B, we can use the same concept to calculate angle E. Angles inside of a triangle, so we're going to subtract out of 180 degrees, we remove the 24 degrees. We also remove the other 24 degrees. By doing this, we are calculating angle E. That is the concept that we are going to simply apply on this triangle, and that was going to give us 132 degrees at the end. So that's it. We have got all the angles in this shape that we are given. All you just need are the properties of the shape also considered with the given lines, properties of the parallel lines that you're given. So these are the typical questions that you must expect in your examinations. Just try to work as much questions as you can. We shall do our revisions. And like I said, join membership also, so that you are not limited in terms of the revisions, in terms of the questions and question papers we shall be having. So that can help you in your preparations for the exams that are ahead of time. But for now, that's it. Till we meet again.